In this lesson is going to be the final one of the class. We're going to use a series of videos to go through lesson 14 about using assemblies. The last lesson we learned how to create an assembly by bringing multiple parts into an assembly, um, mating them, arranging them and how we wanted, and then uh, finally creating a subassembly and also inserting that into an assembly. This we're going to be using an assembly, and we're going to be doing some different things. We're going to analyze the assembly and how we learned before to perform a mass calculation on the properties of a part. We're going to be able to do that for a full assembly. We're going to learn how to edit the assembly while the parts are in an assembly. We're going to create or look at an exploded view. I'm sure you've seen those in different directions where they take an assembly and they basically spread the parts out so we can see how it goes together. And then last, we're going to look at a bill of materials. And a bill of materials is nothing more than a list of all the parts that go into an assembly listed in a chart form, and it tells us a description of the part and how many of them are used in that assembly. And again, that is something that is very common used in manufacturing. And so like last time, the best thing you can do is I've placed a zip folder in this lesson on Blackboard. I would download that to your desktop and unzip the folder so that SolidWorks can access all the files, which it is going to need to do. So we can come up here to File and then Open, and then you can navigate to wherever you've got that file saved and opened. And you can see here in my folder, I've got all these parts of individual parts. And if I've got an even more complicated assembly, I might have, literally hundreds of parts in there. One quick way that we can filter it and find the top level assembly is if I come down here to Quick Filter, and if I go to this last one, I can filter to the top level assembly, and then that lets me open that. So what we're gonna see when we open this is at the top of the screen is what SolidWorks calls is a progress indicator. And what this does, it does three things. First, it's going to open all the components associated with this assembly. Second, it's going to update any of the models. And what that means, if we've gone through and we've updated a part, but we haven't rebuilt the whole assembly, it's going to update that as it opens, and it's going to update the whole assembly with this part, that we edited. And then third, it's going to update graphics, and it's going to generate these assembly graphics. And so it's going to go by pretty quickly, but I'm going to open it, and you'll see this up here at the top. And there's our flashlight. That's what it should look like for you. And so if that is something that you're interested in looking at, you can come up here to Tools, you can come down here to Evaluate, and then Performance Evaluation. And it's going to open this Open Performance. It's going to tell you how long it took to open it, if there are any previous version references, did we modify anything when it was open. It'll tell you the number of parts, number of subassemblies, and then number of components. Again, it's one of those things that you may or may not want to look at. I don't ever use this, but it is in the book and they go through it, and that's why we're bringing this up here. All right, one of the things that they cover in the book here, and I apologize, this is page 494, or page 494 in the book. It appears that the electronic version is missing page 492 and 493. And so I'm going to try to explain it the best that I can. Anyway, there is a chance that if you have a file open already, a part, and then you open assembly, and the part that you have open uses the same name as a part in the assembly, SolidWorks may get confused and try to use the one that's open. And the example that they use in lesson L13, when we did the assembly for bottom up modeling, we had a pin that was just a cylinder. It was a straight cylinder that we used as a pin. This pin uses some, and in this assembly for the flashlight, it uses a pin with a flange on the end of it, and it's much narrower. Now, personally, when I'm opening an assembly, the chances of me having random parts open are probably like next to nothing, but in case this happens, this is what can happen. And so if that happens when you open an assembly and you have a part number or another part open with the same name, uh, you're going to get a message from SolidWorks, and it's going to read the document being opened references a file with the same name as an already open document. And so then what SolidWorks is going to do, it's going to go in and it's going to check the internal diameters of where this pin is supposed to go and decide, give you the option of which one you want to use. And so here's what happens with those options. The two options you have are, I can open without this document, this duplicate document, and it's going to suppress the assembly component in question to avoid any conflicts. And so basically what that means is it's not going to use either pin. And you can see where it's holding this lever. It's supposed to go through this hole right here. It's just not going to use any pin. And the other option is accept this file anyway. And what it does is it opens the already open part as the assembly component. It doesn't use the one that it was already in the assembly previously before opening. And so you can see what happens is it tries to use this pin from the previous assembly, and there's no way that fits in there. And so again, to me, this is unlikely to happen, or at least very often, unless you've got like tons of stuff open and you're opening some random assembly for some reason. But anyway, this is what can possibly happen. So several types of analysis that we can perform on an assembly are going to include mass properties, so materials, weights, of that nature. We can look for interference detection, so if parts are running into each other as they're assembled. And then we can also look for clearance verification to verify certain clearances between assembled parts. So we come up here to evaluate, and mine does not have it. And so what we can do is, if yours doesn't have it either, we can come up into this space in the toolbar. I can right click, I can come to tabs, and I don't need this cam. And I'm going to click evaluate. We'll do markup, sketch, layout, and assembly. We'll say okay. And then I can come over here to evaluate, and I come up to mass properties. So basically what this does is it calculates the mass properties of everything involved in this box that's set up around it. And we can see the mass, the volume, the surface area. It's got center of mass, moments of inertia. So again, whatever we need, we can get from here. I can also click on an individual component, and if I clicked recalculate on that, it would recalculate all these figures just for that component. And so I could go through and do individual analysis as well. So I'm going to delete that. I'll hit this and recalculate. And then options, I can change my options and change my my units of measurement on specific parts or the whole thing, different than what my assembly template comes in at. So it gives us a lot of flexibility on analyzing the part. So we're going to stop this part here, and when we pick up with the next video, we are going to start checking for clearances and interference.